welcome. Thanks for coming. I've already been introduced, but I'll tell you a bit about myself. So I'm the senior data scientist at Catawiki, and my colleague Denis is one of our long-standing data engineers. And we're here to talk to you today about the recommendation systems at Catawiki.
Yeah, so how much of you already know Catawiki? Almost everyone. So we're an online auction platform, and we specialize in collector's items and rare finance. For example, comic books, guitars, Ferrari auctions, but also a lot of Napoleon's hair. We auctioned 40,000 lots per week, and we recently passed 1 million registered users.
Yeah, so the structure of the talk, we're going to start with a quick quiz. After the quiz, we will have a few case studies and then end with a demo at the end. So, Alice, Bob, and Eve all go to Albert Heijn and buy some fruit. And this is what they buy. So Alice gets an orange, banana, apple, Bob orange, Eve orange and banana. Bob comes back the next day and asks you all, as Albert Heijn employees, what would you recommend I buy? So, what should Bob buy? Just shout out the answer. Orange? Any other thoughts? Pineapple. Well, Bob might like a pineapple, but we don't have enough data. Okay, I was hoping someone would say banana, because banana is the answer I was looking for. So I'll give you the answer for banana. So if you look at the buying behavior of Bob and Alice and compare them, they both have bought an orange and an apple. So in terms of buying behavior, Bob and Alice are the most similar users. And since Bob hasn't bought a banana and Alice has, you recommend a banana to Bob. So this is, in effect, user-based collaborative filtering. Taking the problem, flipping it on its head. Which user would you recommend to the apple? It's hard to think of it this way, but no answer is a wrong answer. Shout them out. Eve, yes, of course. Eve gets the apple. No one got the joke. Yeah. Okay, so looking at this another way, co-occurrence of buying behavior. So a banana was bought twice with an orange, an apple twice with an orange, banana once with an apple. So if you were to buy an apple, you're twice as likely to buy an orange as you were to buy a banana, for example. So we'll come back to this in a few minutes, but an interesting way of looking at the data. So what are the business problems at Catawiki? So the list is endless. You can personalize emails, you could improve the website search by personalizing it, improve the content you're showing to users for advertisement, help them discover auction lots quicker, optimize how easy it is to submit lots. So I'm going to talk to you about a few of the projects we have, and the first is the auction listing page recommendations. So the auction listing page for a particular auction category looks like this. Well, this is a screenshot of it. And on the right hand side you have auction lots in the particular auction. This is the maritime auction. And on the left we want something like this: other interesting auctions with the most related auctions to the current auction you're viewing. So this is recommending auction categories to auction categories. So how do we do this? So you have a matrix view, and this matrix has a row for every user and a column for every auction category. In the cells you'd have a number of bids from that user for the particular auction category. So if you take the transpose, take the inner product with itself, you will end up with the co-occurrence matrix, similar to the example earlier. And if you take a row for auction A, in this co-occurrence matrix, sort the other auctions by the value, co-occurrence, you'll get similar auctions to the given auction. So, can we use this? The answer is sort of. There's a few problems with it. The first problem is that popular auctions are overrepresented. And the second problem is that when we add a new auction, there's not as much data from your auctions. So how do we fix these problems? So we normalize. So we do Jacquard normalization, so take the intersection of auction category A and auction category B, and you divide it by the union of A and B. So that's all the bids that are only from users that have bid in A and B, divided by the total number of bids in A and B together. And this, as you can see, it's a lot less sparse, the co-occurrence, and it normalizes everything nicely between 0 and 1. And it mostly solves the popularity and the new auction problem. So how do we do this in production?
Yeah, so how we got this in production from the model that Adam just described to our end users. So basically we have our bits which we load into the data warehouse. So we load them into a Spark. It's a cloud computing framework. And so with Spark we can calculate these recommendations from scratch in a couple of minutes. And when we pre-compute the model and save parts of this model, then the recommendation can basically be computed in a matter of seconds. So then after the calculation, we would feed this to a personalization service, and this is just basically a lightweight REST API built in Ruby using the Grape framework. And from there on we can distribute it over all the different web apps, mobile apps, marketing apps, etc. that we have. So we ran, next slide. So we ran an A/B test on dispatch using these recommendations, and we saw a 3% uplift in simple registrations and also a small uplift in bids. So it was quite successful, and we're launching a couple of other A/B tests around the website using these recommendations.
Okay, next case study. Recommended auctions on our homepage. So our homepage looks like this. You have 8 auctions, you can only see 4 there, but you have 8 auctions that are shown to every user. Currently they are selected manually by our auctioneers, but we would like to personalize them so that people see what they want to see, what interests them. So how do we do that? We use the previous model to create the likelihood that someone will bid in every auction category. So on the data you see here, U represents the same matrix, the row for every user, column for every auction category. It's the inner product of that with the co-occurrence model or with the Jacquard normalized co-occurrence model. And for a given user, I've picked my boss Peter here. He bids on Lego a lot, and it recommends Lego, comics, model cars, jewellery, classic cars. So the co-occurrence model is highly weighted towards popularity, popular auctions. The Jacquard normalized model is more niche auctions. So we have 2 models that provide us with different types of recommendations, and how do we use these in production? So the first step was creating the models. The second step is actually creating a list of 8 auctions that make sense to show. So we have multiple art auctions, for example, and if we want to show auctions on the homepage, we don't want to show 8 art auctions. We want to show more diverse range of auctions. So we need to add in some diversity into the model. There's a popularity novelty trade-off. So we want to display popular auctions, of course, but we don't want to only display popular auctions at the expense of possibly interesting, more niche auctions. So there needs to be a balance between niche and popularity. Serendipity or consistency. So we don't want to see the same recommendations every day, for example, because that's boring. Freshness. If we have new auctions, which we occasionally have, we want to maybe manually weight them higher so that they get more exposure. So people are more aware of them. Some business logic in there, so we maybe want to weight auctions that have higher return on investments higher than other auctions. Interpretability, so this is important to get buy-in for the business. So these were manually selected by auctioneers, and we say we want to replace all what we're doing, and they say, well, how do the recommendations work? And we can explain, given the recommendations they see for themselves, why it was produced that way. So we're currently evaluating an A/B test. So we started one a month ago, and we're evaluating it. So we don't have any results yet to show you. But maybe at the next talk. But you can currently see recommendations depending if you're in the B group or A group, if you go to the website. So some current projects which are in development. User lot recommendations. So we've looked at recommending auction categories to auction categories, auction categories to users. Now it's auction lots to users. So this is a completely different problem. The issue with this is the data is very sparse. So currently we're only beginning to implement the infrastructure to get page views. So we're working off bidding data and unstructured data about the items, so item title, item description. We are currently also implementing what we call facets, which, for example, for watches, it would be Rolex, and it's a gold watch, and it's this many carats. So it's going to, our data will improve a lot, but in the meantime, we want to create lot level recommendations using sparse data with the problem of we have new users, many new users because we're growing so fast, and our auction lots only exist for 1 week on the website. So there's a cold start problem for both users and auction lots, which is quite unique. So how do we solve this? We use all the data. I thought I'd put a meme in here because it's everything needed to look at a meme. User auction lot recommendations. So use Python talk. To include some Python. So Theano is a linear algebra library. People might have heard of TensorFlow as well. Do a similar type of thing. We have a model which is based on low rank in the matrix factorization, but also with feature embedding. So what that means is we have features of the users, so the demographics of the users, features of our lots, so the price, and extract some features from the auction title and a few other places. And we're recommending, given a particular type of user, what particular lots would you recommend. So you're actually recommending features to features rather than individual users to individual lots. So this solves the problem of cold start because you immediately know user demographics and some information about a user which provides you with better recommendations. I think I would talk about this a bit more, but we're running okay on time. So you train this model on the bidding data. So R prime here is the output from the model, and we want to minimize the difference between this, which is the bidding behavior for every user on every item, with the actual behavior. And we use stochastic gradient descent, so we take small batches of user data and we update the latent feature weights, which are these two sort of matrices in the middle, and iteratively update those so that the cost function decreases, and you end up with a prediction of what users will bid on, which we then use to create the recommendations. So there's problems with scaling, which Denis will talk about.
Yeah, so we're talking now about a lot more data than just corresponding auction type with auction type. So we sell over, nowadays it's already 30k auction lots per week, and we have over 400,000 bidders, so it's a huge matrix. And yeah, there are two things that we do there. Basically, you can show 35,000 lots to every user on the website. So we only store a small amount that we can use throughout the website, like 100 lots or maybe 1,000 lots, which are recommended for those users. And next to that, we can do some batch processing. So these recommendations are still fairly slowly changing. It's because it's still based on bits, of course. So, and it doesn't need to be near real time. So we can calculate these recommendations basically every 5 minutes. Then we calculate only small batches of users that just place a bid in the last 15 minutes, something like that. So the next step, of course, is recommendation for everyone, because at this moment we can only recommend auction lots for users that actually place a bid. But when you start on our website and you create an account, of course you haven't placed a bid yet, but we do want to recommend some auction lots for you. So what we're currently building is a snowplow page tracker. So we can track every user on our website. We string this data through Amazon Kinesis or I just forgot the name. Well, for now Amazon Kinesis. You start off. Oh yeah, of course Apache Kafka you can use for that. And we do some basic parsing on it to identify the users. And that we load into Spark Streaming. So Spark has another module, it's a streaming module, which is basically where you can compute the recommendations over micro batches. And in that way we can feed that again to the personalization API. And we hope to have recommendations for every user that comes in on website after he spent a couple of seconds or maybe 30 seconds on a website.
Yeah. So, final case study for us. This is a project that came out of a hackathon we did, and I'll hopefully get to show you the cool hackathon video at the end. So, the auction submission flow recommendations. So what is this? What does this mean? If you go to submit a lot on Catawiki, you are showing this page, and immediately you can see the problem. You have to select from, and you can scroll down this list is twice as long, a list of many auctions, and ideally you would just type the name of your lot and it would recommend the correct auction to put it in. So that was the problem. So the solution, multiple solutions, but I'll talk about the first. So we don't have any structured data about our lots yet. So we took the title of the lot and we parsed it using GenSim, which is a nice library for Python for natural language processing. Did some semantic indexing on it. So basically you have a vector which represents the title in this latent space, and this vector actually represents something. So if you, for example, take king plus minus man, it will give you queen, will be the closest word. So we do that for every auction title, and then we index all of this in Elasticsearch and use some custom scoring functions, is it? Something like that, to actually find the closest items, and then take the top X closest items and find which auctions they are in, and then use that to recommend the top 5 auctions. So given a title, you're searching for similar lots that we previously sold, look at their auctions, find the most common auctions, and then recommend that. So we've implemented it this way. There is a second way. I've implemented it using scikit-learn and XGBoost, which gives us better accuracy, but requires a lot more time to compute, so to productionize Elasticsearch is much faster. So we're going to give you a quick demo of this. Press skip. And then, okay. Yeah, so pick any lot.
Does anyone have something to sell?
Yes.
A coin counting machine.
Well, we've got various coin auctions. We sadly don't have a coin counting machine auction, which is why it doesn't
Sounds a
matter.
bit like a curiosity.
Yeah. Any other suggestions?
iPhone cover.
iPhone cover. Let's see.
It's really a collectible.
Computer collectibles. There we go. Fashion auction. Maybe. One final.
Guitar. What kind of guitar? Oh, Les Paul.
Guitar auction, third one. Oh, must be a lot of Les Paul. Who knew? Okay. So we have another demo. So this originally came out of the hackathon we did a month ago, and we created a video at the end of the hackathon where we had a similar model to this, but we also integrated it with the Google Vision API to create a nice series of events. So you start with press play. And over to you. So you start with, this demonstrates what you've just seen. You type in the auction title and it will find the similar, the correct auction categories. But also, with the Google Vision integration, you can upload a photograph, which, there you go, Ferrari. And this doesn't cheat, it doesn't use the name of the image or anything. You get the hackathon spirit in the Giphy. At some point in the future, there we go. So, Testarossa, Ferrari. So this is an earlier version of the model, so it's a jewelry auction first, but then it's a classic car auction. So it's quite a nice combination of features. You upload an image of what you're selling, it automatically picks the correct auction, gives you a temporary auction title. It's something you might look into further in the future.
I think then we're already there. So, are there any questions?
Small question?
Yep.
Shall I grab the...
Very small question. You mentioned it an alternative for penises.
Yeah.
What was it?
Oh, sorry. Apache Kafka. So you stream and pre-process the click data. Yeah.
Then at the back.
What do you use for A/B testing?
A/B testing. So we have a custom framework which we've built, which we do all the A/B testing, and it allows everyone in the business to set up A/B tests and run them and evaluate them. So yeah.
Yes.
So Catawiki's built using Rails, and we started using, I forgot the name. It's a very popular A/B testing tool. A lot of websites use it, but it really allows you to test the front end basically. And we also want to test things that we change in the back end. So that was one key feature for the decision to build our own A/B test tool.
Any more questions? What's back?
What would the use of? What was the way to check a new member of the Catawiki what they want to see as an auction? You used Amazon Kinesis, but what is it? What is it exactly that you check in those 30 seconds, or to give a recommendation?
Dennis?
Yeah, so it's basically just click data. So of course, when the user first navigates on a website, it clicks on some auctions maybe, or some other registrations, and by comparing that also to clicking behavior of other already existing customers, we can recommend auctions for them. But this is still work in progress, so we haven't, we don't have it up and running yet. We're working on it.
Question in the middle, right.
Hi, thank you. So I was wondering about your evaluation methods while you're developing these algorithms. So do you get your data sets from the live website, or can you elaborate about that a little bit more?
So in terms of evaluation, I suppose there's two ways. You've got your offline evaluation and your online evaluation. So the initial thing is offline evaluation, which, for example, in the user auction lot recommendation, so that's recommending auction lots to users, we actually have a cost function which is based on, it gives a single number effectively. It's I think it's the negative log loss of the difference between the predicted and the actual bidding behavior, and we optimize that, so that's our offline measure. But when you create a machine learning model for recommendations, your metric for offline doesn't necessarily always line up to online. So this is where the A/B testing framework comes in. We A/B test what we think is our best offline model, and then once that's put into production, then we can A/B test different versions of the recommendation engine against itself. So you get online. That's the gold standard. If you have enough data coming through your website, you ideally want to do that with everything. But does that answer your question?
Yeah,
Yep. Thanks. Yes, in the middle.
You seem to be using Python mostly for the statistics stuff, right? Because the most of the other web services or stuff with Ruby or Rails or...
So Python we use, Python and R actually we primarily use for analytics and ad hoc requests. Python is more for the building the machine learning models and training them. And then serving the models we use Ruby, Scala. So there's a separation between training the models and then we save them and then we serve them using a more performant language.
Historical? Why?
I could, for example, use Ruby, but Ruby is not suited to building machine learning models, for example. And there's lots of fantastic Python libraries that already exist, and it's so attractive. Why wouldn't I use it? And then I come to actually using the recommendations if I want to serve them within a few milliseconds. Python can maybe do that, but if we have something like Scala, we know it definitely can do that. Final question, the front.
I saw that you have social registration also. You can register using Facebook.
Sorry?
I saw that you also have social registration using
Yes.
Facebook. Are you using the circles of people to identify what the possible bits are, or not yet?
Not yet, but I had a meeting about that 2 weeks ago. So yes, we will be hopefully getting some Facebook data about users' likes and that type of thing, which is fantastic for creating recommendations. So the base recommendation model will only get better the more data we get and the bigger we get. Okay.
Okay, awesome.